Right now, there's a massive race happening in the tech world. Like, everyone is trying to put artificial intelligence in charge of chemical plants, oil rigs, manufacturing floors, power grids, you name it.
Oh, yeah, it's everywhere.
Right. But we got our hands on a leaked, highly confidential document today, and it makes a terrifying claim. Basically, the way tech companies are testing these AI systems is completely dangerously broken. So, welcome to the deep dive.
Glad to be here for this one.
Because today we are looking at something that isn't, a published article or a shiny PR press release. We are looking at an internal draft document. Right at the top, in bold red letters, it says, draft not for release, see hold conditions.
Yeah, it definitely has that forbidden fruit quality to it.
Totally. And it comes from a company called EON AI Ventures, detailing a project they are calling the Shift Test.
And honestly, the stakes here could not be higher. We are talking about moving AI out of your web browser where, a mistake just means a weirdly phrased email.
Right, like an extra finger in a generated photo or something.
Exactly. But now we're moving it into heavy industry environments where a mistake means a catastrophic explosion.
Okay, let's unpack this. Because the core mission of our deep dive today is to figure out exactly how we are supposed to test an AI in a life or death situation, and why EON says that current industry standard is totally a blind spot. So what exactly is the core problem they're trying to solve here?
Well, to understand the problem, you really have to look at the baseline claim every major tech company is making right now.
Which is what?
They're all developing these massive AI models, and they're claiming these systems can understand and manage complex industrial operations. EON's document isolates this very specific logical proposition. Basically, an AI model trained specifically on historical industrial incidents should naturally be better at managing a plant than just a general AI trained on the open internet.
Well, sure. I mean, you want the specialist, not the generalist. Like, if I need heart surgery, I want a cardiologist, right? Not a general practitioner who just read a lot of medical wikis.
Precisely. It sounds like total common sense. But the document drops a massive bombshell right away.
I loved this part.
Yeah, they point out that this proposition has never actually been measured.
Wait, never?
Never empirically proven. Everyone in the industry just assumes it is true. And the reason they haven't proven it is because the assumed, the obvious way to test an AI on this is structurally flawed.
Let's pause on this obvious test, because before I read this draft, this is exactly how I would have assumed you test an AI for safety.
Why? It's the natural instinct.
Yeah. You take a historical, documented industrial incident, say the Deepwater Horizon oil spill, or some specific refinery fire from a few years ago. You hide the final catastrophic outcome from the AI, feed it the initial temperature and pressure data, and ask, what is going wrong here?
Right. It makes complete intuitive sense. You want to see if the machine can spot the disaster before it happens, based entirely on the breadcrumbs leading up to it.
If it spots the anomaly, it passes.
Exactly. But EON's draft points out that this is entirely unsound. And the reason why is fascinating, because it exposes a major secret about how these massive AI models are built.
Right, the training data.
Right. They are continuously trained on incredibly vast data sets scraped from the entire internet. And tech companies do not, and honestly sometimes cannot, disclose every single document that goes into that training data.
Which means the AI has probably already read the safety report for the very incident you're testing it on.
Exactly. This raises an important question. Are we measuring an AI's ability to genuinely reason through a complex physical problem, or are we just measuring its ability to recall a safety report it already read during its training phase?
Wow.
Because you cannot verify an AI's training cutoff date with absolute certainty, and you certainly cannot verify exactly which safety reports, news articles, or Wikipedia pages it's ingested.
It's like giving a medical student a high-stakes licensing exam, but the student has already secretly hacked the server and memorized the answer key.
That is a perfect analogy.
Right. They sit down, they look at a patient's symptoms on the test, and they immediately diagnose a super rare ruptured appendix. Did they use deductive reasoning to save that virtual patient, or did they just remember that question 42 is ruptured appendix?
And if they just memorize question 42, you have absolutely no idea if they actually know how to hold a scalpel and save a real patient in a real operating room.
It's terrifying.
It is. Now, the EON document does note that other researchers try to fix this by picking more recent historical incidents.
Oh, like things that happened just last month.
Right, hoping the AI hasn't seen the reports yet. But EON argues that just narrows an unverifiable margin. AI models are being retrained so constantly now that the window of unseen data is, well, it's always shrinking.
So the defect is structural. No matter how carefully you select historical cases, you can never mathematically prove the AI hasn't seen them somewhere in its billions of parameters.
Exactly. Historical data is hopelessly compromised by the AI's vast photographic memory.
Which leaves the entire industry at a dead end. We can't trust the tests. But EON proposes a solution by looking backward to find a way forward.
Yeah, they look back about 50 years to a safety standard established by a completely different industry.
Aviation. I absolutely loved this part of the
They're
document.
brilliant.
For some context here, EON AI Ventures isn't just, a new startup that discovered AI yesterday. They have actually been building industrial work simulators for 25 years. And they argue that we need to test AI exactly the way airlines test human pilots.
Think about it. When an airline wants to certify a pilot to fly a 747, they don't sit them down at a desk and give them a written multiple-choice history test about famous plane crashes.
Right, that would be absurd.
They put them in a multi-million-dollar flight simulator. They throw them into a situation governed by real-world physics, a situation that I've never seen before, like a dual-engine failure in a specific crosswind.
And they just watch how they react in real time.
Exactly.
Because there is no answer sheet to memorize. You can't recall the answer from the internet if the scenario is literally being generated by a physics engine for the very first time.
Precisely. And EON calls their version of this the shift test. They basically generate a digital chemical plant or refinery.
With real physics.
Right, the equipment behaves like real equipment based on thermodynamics and fluid dynamics. So the specific combination of pressures, temperatures, and valve positions has never occurred before in the history of the universe.
What's fascinating here is how this forces a fundamental shift in how the AI operates. Like, it bridges the massive gap between theoretical knowledge, which language models are incredibly good at, and practical real-time application.
The AI can no longer just rely on pattern-matching text from a historical archive. It actually has to calculate the physics, read the live instruments, and deduce the physical state of the plant.
And the document lays out the exact prompt they use to test the AI inside the simulator, and it is so remarkably human.
It's not a complex string of code at all.
No. So in industry, a shift is the unit of work, right? The 8 or 12 hours a crew is responsible for a plant. And the benchmark asks the AI the exact question a human crew asks when they hand over the plant to the next shift.
Right.
It asks, given only what can be seen right now, what is most likely to hurt us before the next shift ends, and what check would confirm it?
It is a brilliant framing because of what it demands from the AI. It demands immediate spatial awareness. It demands predictive reasoning because it asks what will happen, not just what is happening.
Right. It's looking into the future.
And it demands a concrete action plan by asking what check would confirm the danger. It's actively forcing the AI to step out of the abstract realm of text generation and into the physical reality of the workers whose lives depend on it.
So picture this. The AI is inside this digital simulator. It's looking at the gauges, it processes the physics, and it spits out a prediction about what's going to hurt the crew. Now comes the hard part. How on earth do you score that fairly?
Yeah, that's the tricky part.
Because EON is absolutely adamant in this draft that we cannot just give the AI a standardized grade like an 85 out of 100.
They argue that collapsing the score into a single number is actively dangerous in an industrial context.
But why? I mean, we use single numbers for everything. You have a credit score, you get an SAT score, your phone has a battery percentage. It's how we quickly understand performance.
Right. But a single number conceals exactly how an AI might fail.
Okay, give me an example.
Let's say an AI gets a 95% overall safety score. On a marketing brochure, that sounds fantastic, right?
I'd buy it.
Exactly. But what if it earned that 95% by being absolutely perfect at identifying minor, harmless pressure fluctuations in the water pipes?
Okay.
But the 5% it failed on was completely ignoring a catastrophic lethal gas leak.
Oh, wow. Yeah, that's a problem.
In a heavy industry environment, you don't just need to know that a system is mostly good. You desperately need to know the specific shape of its blind spots.
Okay, that makes terrifying sense. So to fix this, EON strips away any identifying markers of which company made the AI. So it's graded totally blind, and they score it across very specific independent dimensions.
Right.
Now, identification makes sense to me, like, did it name the hazard correctly? But then they list actionability. What does it actually mean for an AI's response to be actionable?
Well, actionability means the AI isn't just stating a problem. It's providing a usable solution for the human operator.
Okay.
If the AI says the pressure in reactor 4 is dangerously high, that is true, but it's not actionable. The operator is left scrambling to figure out what to do.
They're just panicking.
Right. An actionable response is, the pressure in reactor 4 is dangerously high, manually open pressure relief valve number 7 to vent the system.
Oh, so it has to actually tell you which lever to pull?
Okay.
Got it. And what about calibration? Is that like making sure the AI's confidence level actually matches its accuracy? So if it says it's 99% sure a pipe will burst, it better burst 99 times out of 100. But if it's only 50% sure, it shouldn't pretend it's a sure thing.
You nailed it. Calibration measures self-awareness. An uncalibrated AI might be wrong, but express 100% confidence that it's right, which leads human operators to take drastic, incorrect actions.
Right. Here's where it gets really interesting, though. They have an entire dimension completely dedicated to false alarms.
Which, as the document points out, carries far more weight in the real world than software developers usually realize.
They actually call it the crying wolf track. The document states that serious, life-threatening industrial events are actually incredibly rare. So what happens if you have an AI that is hypersensitive? It catches every single real hazard perfectly, but to do that, it also throws 100 false alarms a day.
It creates a phenomenon known as alarm fatigue.
Right. You've probably experienced a mild version of this yourself. Think about that one smoke detector in your house that always goes off every single time you make toast.
Yep, the toast alarm.
After a few weeks of that, what do? You pull the battery out, right?
Exactly.
Now imagine doing that in a multi-billion-dollar refinery. If the alarm goes off every time the wind blows outside, human psychology dictates that the crew will eventually start ignoring it. Or they'll just switch it off completely.
Exactly. An AI that cries wolf defeats the entire purpose of a safety system because it actively trains the human operators to ignore the safety system. The document literally states, any benchmark that omits this measures the wrong thing.
I love that. But wait, if he severely punished the AI for throwing false alarms, doesn't that just make it terrified to report anything? Isn't an overly silent AI just as dangerous?
That is the exact tension they're managing, which brings us to another critical dimension, abstention.
Abstention.
Right. This measures whether the AI system is capable of declining to answer when the evidence genuinely does not support a firm conclusion.
Like testing if it's willing to admit it just doesn't know.
Precisely. One of the most well-documented and dangerous flaws of modern large language models is their tendency to hallucinate.
Oh yeah, making things up.
Right. They confidently invent information when they don't have the real answer because they are programmed to be helpful at all costs. In a web browser, if an AI hallucinates a fake book title for your essay, it's annoying.
Right.
In a chemical plant, if an AI hallucinates a fake safety protocol because it's too arrogant to admit it lacks sensor data, people die.
Wow. So abstention is literally testing the AI's humility, its ability to know its own limits, look at the gauge, and state honest uncertainty rather than making up a story.
It is arguably the most important metric for any autonomous machine we trust with human lives.
Okay, I am fully on board with the simulator idea, but as I'm reading this architecture, a massive objection pops into my head. And to be fair, EON actually anticipates it in the document.
They do, yeah.
Look at the setup here. EON is using a machine simulator to generate the test scenario. Then a machine AI is taking the test. And presumably, a machine algorithm is checking the data to score it.
Right.
Aren't we just stuck in a giant machine loop? It sounds like having a student write their own test, take their own test, and then grade themselves. Of course they're going to get an A+.
Yeah, it's a valid concern.
How do we know this isn't just an echo chamber where algorithms are just nodding in agreement with other algorithms?
It is the most critical vulnerability of their proposed system. If correlated systems are just validating each other, the test is useless. It doesn't reflect the real world.
Right.
But EON defends the shift test against this by implementing 3 distinct human-driven validation checks to forcefully break that machine loop.
Let's walk through them because they are pretty intense. The first check is basically a Turing test for industrial engineering. They take the situations generated by the physics simulator, they mix them up with real historical incidents, and they show them blind to working veteran process safety engineers.
And the rule is simple. If the human engineers can reliably tell which scenarios are generated by the machine, better than random guessing, meaning the simulated scenarios feel fake, or the physics feels slightly off weak, EON rejects the entire generation method.
That is a wildly high bar. The simulated physics must be completely indistinguishable from reality to people who have spent their entire lives walking the floors of these plants.
Exactly.
And no AI model participates in that check at all.
Right. Then there's the second check. Human domain experts, not the machine, and not the developers who built the simulator, write the reference answers.
Oh,
The
okay.
answer key is authored purely by humans looking at the scenario.
That makes sense. But the third check is the one that really melted my brain.
Yeah, this one is clever.
It really is.
If we connect this to the bigger picture, EON has to definitively prove that their simulator is testing the exact same underlying capability as the real world. So every AI contestant is tested on the generated simulator scenarios, and they are tested on the historical documented incidents.
Wait a minute. Didn't we just spend the entire first half of this deep dive establishing that testing on historical incidents is completely broken because of data memorization?
Yes, it is broken for establishing an absolute trustworthy score, but it's highly useful for establishing a relative ranking between models.
Oh,
Here's the mathematical genius of the third check. If AI model A beats AI model B on the memorized historical data, then model A must also beat model B on the unseen simulator data. The ranking of the contestants must hold steady across both sets.
Oh, I see. Because if Model A is genuinely the smartest system at understanding industrial physics, it should win in the historical arena and it should win in the simulator arena.
Right.
If the rankings flip-flop, it means the simulator isn't testing reality, it's testing something else entirely.
Exactly. And the document points out a beautiful piece of logic here. EON cannot arrange to pass this check because they do not control the competitors.
Right, they're testing everyone's models.
Yeah, most of the AI systems taking the test will be built by other major tech giants. EON has no access to the back end of their competitors' models, so they can't artificially tweak the results to make the rankings match. It ensures an inherently level playing field.
Okay, so if this test is so incredibly bulletproof and it solves this massive industry blind spot, why is this document marked not for release? What on earth is EON waiting for?
That is the million-dollar question.
Which brings us to the final and definitely the most secretive page of this leaked draft, the hold conditions. This is their internal checklist, and it reveals a strategy of radical transparency.
The document outright admits a hard truth. No evaluation is completely free of bias. Their defense against accusations of bias is to simply make every point of potential manipulation painfully visible to the public.
Just putting it all out there.
Right. They are committing to publishing their entire simulator construction method. They are using answer keys written by non-EON staff. And crucially, they're handing the complete scoring set over to a neutral third party to administer.
But they have this strict, unbending internal sequence they absolutely must follow before any of this goes public. The checklist says they must file a provisional patent for their situation generation method first.
Yeah, they have to protect themselves.
The memo states, and I quote, "Publishing afterwards costs nothing at all. Publishing beforehand cannot be undone."
They're dealing with a very strict legal concept known as absolute novelty.
Absolute novelty.
Right. In patent law, especially in many international jurisdictions, if you publicly describe a new method or invention before you file the official patent paperwork for it, you instantly forfeit your right to patent it forever.
Wow. So it instantly becomes public domain.
Exactly. EON wants to release everything openly to the industry, but they need to secure their intellectual property receipt first.
Got it. There is also a fascinating sequencing note in the hold conditions regarding something called EON Delta.
Yes.
Apparently, EON AI Ventures has their own AI model they are developing in-house. But the internal mandate is that they must announce this shift test benchmark first before they ever release their own AI model to the world.
It's a very calculated, necessary move to protect their credibility.
How so?
Well, think about the optics. If EON releases their fancy new AI model to the market, and then a week later says, "Hey everyone, look at this new safety test we invented, and wow, what a coincidence, our model happens to be the absolute best at it,"
Oh, I see.
everyone would rightfully accuse them of rigging the game.
They'd say, "We built the exam before we finished the student, and that was deliberate." That's an actual draft quote from an executive in the document, by the way.
It's a smart move.
And the other executive quote in here, honestly, it's a mic drop for the tech industry. They write, "We would rather publish a test we might lose than keep making a claim nobody can check."
That is incredible.
Right. They are actively, openly preparing to publish their own losses. They fully expect their own in-house AI to fail on some of these rigorous dimensions, like abstention or false alarms.
And they are committing to publishing those failures so the industry finally has a real, honest baseline.
Exactly.
It is a remarkable stance. It actively shifts the entire industry's focus away from flashy marketing claims and back to empirical, checkable reality.
So as we wrap up this deep dive into this leaked document, let's just sort of summarize the massive paradigm shift happening here. We are witnessing a desperate attempt to move away from testing an AI's ability to memorize the past and testing its ability to reason through the future using strict, real-world physics in a simulator.
It is the exact difference between a student who flawlessly memorizes a medical textbook and a student who can actually pick up a scalpel and perform the surgery when things go wrong.
So what does this all mean for you? Why should you, listening to this right now, care about the shift test? You should care because AI is no longer confined to writing polite emails or generating funny pictures on your phone.
No, it's way past that.
It is actively, right now, being integrated into the physical high-stakes environments all around you. Power grids, refineries, manufacturing plants. The places where a failure doesn't mean a glitchy web page, it means an explosion.
Yeah.
The way we measure AI's competence in these spaces will literally save lives. It means we, as a society, must start demanding proof of reasoning over proof of recall.
We have to know the machine understands the physical world, not just the words humans use to describe the world.
Absolutely. But I want to leave you with a final, slightly haunting thought to mull over. One that builds on a very specific fear EON expressed deep in this draft.
Oh, the training data loop.
Right. EON noted that they are handing the shift test over to a neutral third party for a very specific reason, because any published test is quickly absorbed into the open internet, which means it eventually gets sucked into the next round of AI training data.
The machines eventually eat every test we give them.
Exactly. So here is the question that lingers. If every single benchmark we ever create to test AI is eventually just memorized by the machines for their next software update, how will we ever truly know when an AI has achieved genuine independent reasoning versus just having a perfect, unerasable memory of every test humanity has ever written?
The muddy waters just keep getting deeper.
They really do. We'll leave you to think about that one.